Hi, this is Lucas Jellema. It's Monday the 25th of October. It's 10:15. I'm back in my hotel room after presenting at JavaOne, a Birds of a Feather session. It started at 9, about Docker, Vagrant and Puppet. And although the session was quite nice and I got a good response from the audience, I feel bad about it because my demos failed. Despite extensive preparation, and I can think of no other explanation than the network setup in the room in which I presented. But anyways, I got a very bad feeling about it, so I decided to immediately after the presentation record the demos that I would have shown the audience and make them available along with the rest of the material for the presentation, so hopefully the audience will still get the essence from them. The presentation dealt with Docker and how Java developers could make use and can make use of Docker together with tools such as Vagrant and Puppet to set up very efficient environment management for their own personal development environments, basically their laptops. In my first demo, I would like to show how I can use Vagrant to create through VirtualBox a Linux virtual machine with Docker support in it, with the Docker host enabled. That's not something I need to do anything about. That's what Vagrant will do for me when I ask Vagrant to run what is basically a Docker container. In this case, it will be a Docker container based on the NGINX image. Vagrant will realize, since it's running on Windows, that it cannot run a Docker container natively, and therefore it will first create the Docker-enabled Linux virtual machine that you see on the slide. Subsequently, it will create the Docker container based on the NGINX image, and it has been configured to forward port 80, forward traffic on port 8080 in the Docker host to port 80 in the container, which basically results in the fact that from the Windows machine, the ultimate host, we can access on port 8080 the NGINX engine running inside the container. This is what I showed in the presentation. Then I switched to the demo, and then it all broke down. So let's see whether I can do better this time. Go to the command line, and on the command line I simply type vagrant up. This statement will interpret a simple configuration file, which I can show in a moment, and based on the configuration file it realizes that it has been asked to run an NGINX container, a Docker container, so it realizes it needs to run a Docker host machine. It doesn't have to create the Docker host machine, it has been created before, but it has to run the Docker host machine, and that's exactly what it is doing right now. It'll take some time, and at this point my demo failed, and now an hour later it is running, and it must be the network. I can't think of any other reason. Anyways, as you can see here, the container has started, which basically means that the Docker host virtual machine is running, and inside the Docker host, the container based on the NGINX image has been started as well. This in turn should mean that we go to our browser and we access at 10.10.10.29 the IP address for the Docker host VM. We access port 8080. Before it didn't connect to anything. Now when we reload, we see the NGINX default welcome page. Now we have connected to the container. If I return to the command line and were to type vagrant hold, the container will be stopped, not the Docker host VM. And when I switch back to the browser and Ctrl F5 refresh, I will be unable to connect because the container has been brought down. Bring it up again. Will take a little bit of time. Now it's running, and I switch to the browser, Ctrl F5, and I'm back in business. Let's now go into the Docker host. So we leave the world of Windows to enter the world of Linux. We enter into the Docker host with Vagrant SSH. Here we are inside the Docker host, and using the command docker ps, we can see that a single container is currently running. That's the container we started using Vagrant from the Windows environment. I could type curl localhost 8080 and also get the default welcome page returned from the Docker container. I could go inside the Docker container. I could also start additional containers. Let me do that. Let me step into the demo files for this particular demonstration. And let's open this file. And in this file I've got a number of instructions to run additional containers based on the same Docker image. Copy and paste these in. And now I've just started 3 more containers. With docker ps I can check whether these containers are running, and we can see 4 of them are running with various port mappings. 92, 91, 90 and still 8080. So we've got 4 containers running. In the browser we can use 90, we can use 91, we can use 92, and we cannot use 19.3 because no container has been started with port forwarding from the Docker host at port 93. As you hopefully have seen, it's a very simple operation to start additional containers. It takes hardly any time at all, basically because what happens when a container is started is very lightweight. And here the whole idea of lightweight, mean container management is demonstrated very nicely. Using 2 commands, I can stop and remove all of the containers. So now no containers are left. Docker ps will show nothing. Docker ps min, which also shows the stopped containers, will show nothing because the containers were deleted. And of course, when I return to the browser, none of the previously used ports will return. Now it looks like NGINX is running. With Ctrl F5 and a hard refresh, it's unable to connect. So here ends the first demo, in which we have seen how using Vagrant we started the Docker host Linux virtual machine with Docker support inside, and had Vagrant start the Docker container based on the NGINX image and define the port forwarding as well. This was all done based on the Vagrant file we haven't seen yet. And in this Vagrant file we see a number of things. It uses the Docker provider, which basically tells Vagrant to create a Docker container. It specifies the name of the image, NGINX. It specifies the configuration details for the Docker host virtual machine. This file, the Docker host Vagrant file, contains, for example, memory settings and folder mappings. And finally, it specifies the port forwarding, mapping port 80 that's running inside the container to port 8080 on the Docker host Linux file system. And this is the end result that we've seen. So, first demo, I will record the other 2 subsequently.